Approximately 10 to 300 parsecs, 30 to 1,000 light-years, from Earth, a near-Earth supernova is an explosion caused by the death of a star that is close enough to the planet to have an impact on the biosphere. Over the past 11 million years, there have likely been 20 supernova explosions that have occurred within 300% of the Earth. There are 12 such OB associations within 650 pc of the Earth, and Type 2 supernova explosions are predicted to happen there. There are now 6 potential near-Earth supernovae within 300 pc. Every 240 million years on average, a supernova explosion takes place within 10 parsecs, 33 light-years, of the planet. The majority of the harmful impacts that a supernova can have on a planet with life on it are caused by gamma rays. Gamma rays on Earth cause the radiolysis of diatomic N2 and O2 in the upper atmosphere, turning them into nitrogen oxides and reducing the ozone layer to the point where the surface is exposed to dangerous solar and cosmic radiation, mainly ultraviolet. The base of the marine food chain could be severely depleted as a result of the impact on phytoplankton and reef populations. Odenwald analyzes the potential impacts of a Betelgeuse supernova on the planet and on human space travel, focusing on the implications of the stream of charged particles that would reach Earth approximately 100,000 years after the explosion's initial light and other electromagnetic radiation. Large stars as Type 2 supernova candidates are frequently the subject of speculation over the effects of a nearby supernova on Earth. In as short as a millennia, a number of prominent stars within a few hundred light-years of the Sun are candidates to go supernova, 1,000 years. These predictable supernovae are regarded to have minimal potential to damage Earth, despite the fact that they would provide a significant sight. More than half of the Earth's ozone layer would likely be destroyed by a Type 2 supernova if it occurred within 8 parsecs, 26 light-years. These projections are based on the measured radiation flux from SN 1987A, a Type 2 supernova in the Large Magellanic Cloud, and atmospheric modeling. Supernova estimates range from 0.05 to 0.5 per billion years to 10 per billion years for regions within 10 parsecs of the Earth. Supernova explosions close to the Sun often take place over the roughly 10 million years that the Sun takes to travel through one of these zones, according to several studies, which imply that supernovae are concentrated in the spiral arms of the galaxy. The Geminga and Vela supernova remnants are 2 examples of reasonably nearby supernovae. If they happen close enough to the Earth, Type Ia supernovae are regarded to be the most deadly. It is likely that a supernova that could have an impact on Earth will happen unexpectedly and occur in a star system that is not well known because Type Ia supernovae are born from faint, common white dwarf stars. Ik Pegasi is the most likely contender. However, it is currently believed that by the time it may pose a concern, Ik Pegasi would have reached a safe distance due to its velocity in respect to the solar system. Daughter products of short-lived radioactive isotopes provide evidence that a nearby supernova may have even sparked the formation of the solar system, which in turn may have helped set the solar system's composition 4.5 billion years ago. The chemistry of life on Earth was finally made conceivable by supernova creation of heavy elements over astronomically long periods of time. Metal isotope fingerprints from previous supernovae may be found in rock strata on Earth. Later, scientists from the Technical University of Munich reported finding iron-60 enrichment in deep-sea rock from the Pacific Ocean. The top 2 centimeters of crust had 23 atoms of this iron isotope. This layer corresponds to times from 13.4 million years ago to the present. According to estimates, the supernova had to have happened within the previous 5 million years, because else there would not be as much iron-60 left on Earth today. A mass extinction would have likely resulted from a supernova occurring so close, but that did not occur during that time period. The iron content appears to suggest that the supernova was not more than 30 parsecs away. However, the frequency of supernovae at a distance less than d, for a reasonable small d, is estimated by the authors to be roughly d/10 pc, 3 per billion years, giving a likelihood of only about 5% for a supernova within 30 pc in the previous 5 million years. They note that as the solar system is moving into the Milky Way's Orion arm, the likelihood may be higher. A team from Munich discovered interstellar dust and Antarctic surface snow in 2019 that they associate with the local interstellar cloud. The measurement of the radionuclides Phase 60 and MN53 by highly sensitive accelerator mass spectrometry, where Phase 60 is once again the clear signature for recent near-Earth supernova origin, was used to find interstellar dust in Antarctica. Betelgeuse, one of the brightest stars in our sky and a member of the well-known constellation Orion, is one star that always comes up when the subject of supernovas is discussed. Supergiant star Betelgeuse is one. It is extremely smart at its core. However, such talent has a cost. One of the most well-known stars in the sky is Betelgeuse because it will eventually explode. Given Betelgeuse's immense energy, the fuel must be used up rapidly, relatively speaking, that is, and Betelgeuse is actually getting close to the end of its useful life. It will eventually run out of fuel, collapse under its own weight, and then explode in a stunning Type II supernova someday soon, astronomically speaking. When this occurs, Betelgeuse will become extremely brilliant for a few weeks or months, maybe reaching full moon brightness and becoming visible in the daytime. What time will it occur? No one really knows for sure, but most likely not in our lives. It might occur tomorrow or a million years from now. Any living thing on Earth will witness a stunning occurrence in the night sky when it does occur, but no harm will come to terrestrial life. This is due to Betelgeuse's distance of 430 light-years. First, supernovas come in two main varieties. A huge star that has grown old and collapsed is a Type II supernova. Within 50 light-years of Earth, no stars with sufficient mass exist. When a small, dim white dwarf star collapses as a result of a companion's infalling material, a Type I supernova occurs. We are unsure of the precise number of these stars because they are faint and difficult to find. Within 50 light-years, there are probably several hundred of these stars, although none are known to be on the verge of exploding. The closest contender for a supernova progenitor is the star Ik Pegasi b. About 150 light-years from our Sun and Solar System, it is a member of a binary star system. Ik Pegasi a, the system's primary star, is a typical main sequence star, much like the Sun. The other star, Ik Pegasi b, a huge white dwarf that is incredibly tiny and compact and orbits Ik Pegasi a more closely than Mercury orbits the Sun, is the probable Type I supernova. It is anticipated that the white dwarf will expand to a radius where it can accrete stuff from the red giant star A's extended gaseous envelope. The B star may collapse on itself and erupt as a supernova when it becomes large enough. Read more from Phil Plait at Bad Astronomy on the Ik Pegasi system. Nobody is aware. Scientists suspect that earthly animals, possibly even humans, have already undergone alterations due to the high-energy radiation from supernovas. According to one estimate, a potentially hazardous supernova explosion could occur close to Earth once every 15 million years. Another claims that supernova explosions typically happen every 240 million years near 10 parsecs, 33 light-years, of Earth. You can see that we truly don't know. However, you may compare those figures to the planet's age of 4.5 billion years and the few million years that humans have been on it. And if you do that, you'll notice that a supernova is unavoidably going to happen close to Earth. But probably not in the human race's near future. In conclusion, how far should you stay away from a supernova? Earth would need to be at least 50 light-years away from the exploding star in order to survive a supernova. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.